To break even betting at minus 110 odds, you need to be right 52.4% of the time. And you don't need any sophisticated technology to prove that. Like here, I've written a short proof. But instead of the mathematical proof, what I want to do is use this question, which we can solve this way, use it as an excuse to introduce some of the great tools that are available in Python for doing this sort of data analysis and for doing like simulations of random processes. And not only are all of these tools free, but you can even use them without installing anything on your computer. So for example, I'll include a link to the notebook like this, and let me show you what will happen if you follow that link. So first you get a copy of the notebook, and if you try to edit it, it won't let you, but all you have to do is click this duplicate button, then sign up for an account on DeepNote, which is free, and then you'll be able to edit it and you'll be able to run the code the same way that I'm doing it. And some alternatives to this, if you want to still be working online as opposed to locally on your computer, then you could also do this in Google Colab, like by downloading this file and then uploading it to Google Colab. Or another option, if you want to work on your own computer, is you can install Anaconda or anything that contains Jupyter Notebook, and then you can load this notebook into there, and it should work. But what I would recommend, as long as you are comfortable like signing up for a DeepNote, is using that. So first thing I'm going to do is import these 4 different libraries that I want to use. They're pandas, NumPy, scikit-learn, and the one I know least well and the least famous one is Altair, but it's a visualization library, and I just recently discovered it, maybe about 2 weeks ago, and I already feel like I'm much more comfortable with it than I am in Matplotlib, which is the default visualization library in Python, and yeah, that one I've been using for years, but I've never felt super comfortable with it. Okay, let's start on part 1, which is about how do we simulate one of these bets. So let me make a new cell. You evaluate cells by doing shift plus return or shift plus enter. And so first thing I need is some way of like simulating a random process. And this is fairly new to me, but in NumPy, so what I used to use is something called random. And I think that is still fine. And then later on in this video, I want to use something called choice. And so notice here that it says instead you should use this random, this default RNG. Okay, stands for random number generator, I believe. And so I'm just going to start using that from the beginning. So variable name, I'll call it RNG, is numpy.random and default RNG. Okay, so this creates a new instance of some random number generator. Okay, and now I can use this very similar to that np.random that I'm used to using from before. So what this does is it chooses a random number uniformly distributed between 0 and 1. And so that's going to be the source of all the randomness in this computation or in this simulation. And if I want to, say, simulate this thing not just once, but 10 times, that's very easy. I can just put a 10 inside the parentheses here. And then say I want to simulate, did some event with a 70% likelihood happen? Well, here's one way to do that. I can say, how often from these like random outcomes was it less than 0.7? Okay, and that should happen with a probability of 0.7 or likelihood of 70%. So if I were to count how many trues there are in here, I wouldn't expect it to be exactly 7, but should be approximately 70% of whatever number I put here. And so how can I count those? Well, I'd say like maybe the most straightforward way that I know is to first turn it into a list as opposed to a NumPy array, which is what it was before. And then once I have a list, I can use the count method and say, how often did true occur? So there it occurred exactly 7 times. There it occurred 9 times. There it occurred 6 times. So that is one option. Okay, and then another way. So let me give you the intuition behind this first. So this list and then parentheses, that was telling Python, convert this thing, like, what was this thing? So if you ever want to know what something is in Python, you can wrap it in the function type. Okay, that was a NumPy array. And so wrapping it inside this list, that was saying convert it into this more basic Python object, a Python list. So I can do the same sort of thing with this Boolean value true. I can say convert that to an integer, and Python converts that to a 1. And if I say convert false to an integer, it converts that to a 0. And so another way that I could count how many times does true occur in here is I can say add these up. And so adding true plus false maybe doesn't make so much sense. So I believe what happens is that these get converted to ones and zeros, and then summing them, that's the exact same as saying how many ones were there in that list of ones and zeros, or that NumPy array of ones and zeros. And again, each time I do this, I might see a different value. Okay, good. So let's work on writing a function that will simulate making a bet. Let's start at plus odds because I think those are a little easier for me. So like example of a bet at plus 200 odds. Okay, we bet $100. If we win, we get $200. If we lose the bet, the $100. And so let's try to simulate that. And I'm going to call this sim plus, where the plus stands for this is a plus 200 bet, as opposed to like a minus 200 or a minus 110 bet, because the formulas are a little asymmetric between plus and minus. And then the inputs to this function are going to be the true probability, like the probability we're correct, like the 70% from up here. The odds, so that should be something like this, plus 200. And reps, which will be like how many times do we repeat the experiment? So that's like the analog of this 10 here. And then I want to know how much money do I make if I like keep making this bet over and over again for reps number of times. So let's say tot equals 0 for the total value. And then I want to repeat it reps number of times. So the usual syntax for that is to say for I or any variable in range number of repetitions we want. And then what do I want to do? So let me show you the wrong way to do it first. So I could say if rng.random less than true prob. Okay, so the syntax I use is going to be right, but there's going to be a subtle mistake in it. Okay, so this corresponds to winning. Like, for example, the bigger the true probability is, the more likely we are to win. So then if we win, then we get the odds added to our total. Okay, so we're just assuming that we're always betting $100 in this example. And then else if, okay, I mean, it's hard for me to even write this because I know it's wrong. So the negation of this is greater than or equal to true prob. Okay, and then we lose the money. So tot equals tot minus, not minus odds, we lose the amount that we bet, which for these plus bets, we're going to assume is always $100. And so if you've done a lot of programming before, maybe you see what the mistake is. The mistake is that this thing here could be totally different from this thing here. So we really want to just do it once. So one way to do it would be something like x equals this uniformly distributed random number between 0 and 1. And then at the end of the function, we can return TOT, okay, the total value. And so this is correct. I think it probably adds a little more computational time than we need, because if this is not true, then this is always going to be true. So I think it would be a little faster, instead of saying else if, to just say else. And so let's check it. Let's see. So say this is a really good bet. So say the true probability is 50-50 that we win or lose. But say we're getting plus money, so we have a plus 200 bet. Okay, or maybe it looks nicer to just have 200. It's up to you, both are fine. And then repetitions, let's say it's 10. So for this small number of repetitions, even though it's a really good bet, we lost money. We lost $100 at the end of this. Okay, but here we made $800. Okay, and for so few repetitions, you'd expect some randomness here. So let's try increasing it. Let's increase it to 10,000. And so it's a little strange that this value increases so much, just because we try to make the simulation more accurate by using more repetitions. And that's because we're returning the total rather than the average. And I think returning the average makes a lot more sense. So instead of just returning the total, let's return total divided by repetitions. Okay, and that's looking a lot better. So on average, we're making like $50, it looks like. And if we increase this to 100,000, and maybe these zeros are getting sort of hard to read. In Python, you can't do exponent 5 like this. If you want to do 100,000, you have to do star star for exponents. Okay, and these values are seeming pretty consistent. So let's do the same thing for a minus odds bet. So if it's minus 200, then for me, the easiest way to think about it is if you bet 200 or bet whatever the negative of the odds is, then if you win, you get $100, and if you lose the bet. And so I'm going to change the name of the function to sim minus. Okay, this part stays the same. So this says if we won the bet, then we add 100. So this asymmetry is why I wanted to break this up into two different function definitions. And otherwise, up here we lost $100. Here we lose the bet. So minus odds, maybe that looks right. But remember, odds is going to be some number like minus 200 or minus 110. Okay, so if we want total to be going down in that case, then it should really be a plus odds. And before I test this out, I want you to think, say you have a 95% chance of winning. Okay, so a 0.95 true probability of winning. What odds would be fair for that? Okay, well, that's about 20 to 1, your chances of winning. And so I think it's exactly 20 to 1, depending on what you mean by 20 to 1. And so it's not quite that it should be minus 2,000, should be minus 1,900. And so because this is a perfectly fair bet, okay, because 95% is the break-even percentage for minus 1,900, I would expect this average return to be pretty close to 0. Okay, I'd expect it sometimes to be positive, sometimes to be negative. Okay, so there it's like negative 1.16. Let's try it again, negative 0.6. Okay, there on average we're making 12 cents per bet. Okay, so that seems pretty good. And now what happens if I increase this to 97% as my true probability? So this is a good bet, not a great bet. And let's see what our average return is. 38, 39.96. Doesn't that seem a little strange that I'm only 2 percentage points ahead of the true odds, but I'm still like making so much? Okay, whereas in this one up here, like the break even probability for this would be 0.33. So I was about 16 or 17% ahead here. Okay, but it was a very similar outcome. And do you see what the difference is? So the big difference is that here, each time for the way I've written this simulation, I'm risking $1,900. Whereas up here on this part, here I'm always risking $100. So yeah, it looks like I'm making almost as much money with this sim minus bet, but that's because I'm like wagering so much more. So it's really better to instead look at the return on investment. So not just the average return, but the average return divided by how much you risked. And I don't know if this would work if I didn't have it in parentheses. It depends on whether Python does it from left to right or from right to left. But at least for me, I've never learned that and never memorized it. So for the Sim Plus, we're always risking $100. Okay, and so this is going to be the return on investment. And so let's look at this one again. So it's going to go down a lot because I'm dividing it by 100 by the bet size. So you should think of this as like saying, on average, we're making like about 50% return on our investment. So it's still a great bet. Okay, and let's do the same thing here. And if I did times 100, that wouldn't be correct because that's not our bet size here. Okay, instead the bet size is negative of the odds for the way I've written it here. So let's write this as negative of the odds. Okay, so for example, if the odds is minus 200, then my bet size is positive 200. Okay, and this number is going to go down a lot. Okay, so here it's a good bet. Oh, we're making about 2% return on our investment. Okay, and to me that sounds a lot more accurate. And so this is pretty good, but it's a little slow. So for example, let me time how long this takes. Okay, and I'm going to use what's called a magic function that works inside these IPython notebooks. So this runs this computation a few times and times how long it takes on average. So, I mean, it's not too bad, 53 milliseconds. Okay, well, what if I want to do it 1,000,000 times? Okay, then it goes up by about a factor of 10. So this is about half a second, a little over half a second. And let me see if I can get this to work a little faster by using some of these ideas that we were using up before about don't just make one random number at a time, but make a bunch of random numbers at a time. And so let's see. Let me take this as our template for Sim Plus. And let me change the name to Sim Plus 2. And so really all we care about is how many times did we win and how many times did we lose. So wins, well, how many times are we going to repeat the experiment? We repeat the experiment reps number of times. So like up here, we did 10 experiments. Here we're going to do reps experiments. So I can do rng.random reps. And you should imagine that this makes an array of uniformly distributed random numbers between 0 and 1, and there will be reps of them. So like in this case, there would be 1,000,000 of them. And then I want to know, how often was this less than the true probability? Okay, and then we can sum this. Okay, so that's the number of wins. Then losses will be reps minus the wins. And then for each win, we want to add the odds. So wins times whatever the odds were. And then for each loss, we want to lose $100. So let's try that. So let's start with our original one again, and let's go back to this good bet. Plus 200 odds with, okay, I'm going to make it a little faster, and I'll tell you why in a second. So this is our old way. So 543 microseconds. Okay, but that's faster than before just because I decreased the number of repetitions. And let's try it now with our NumPy function. So this is pretty bad. Like this is, I guess, 2,290 microseconds. So this is like 4 times worse. But I thought I told you that this was going to be better. And so it turns out that instead of using this sum, you should use some other built-in NumPy function called count non-zero. Okay, and let's try it again. So it only took 8 microseconds, so that's a lot better than this 500 microseconds, and it's a lot better than those 2 milliseconds from before. Okay, good. So let's take that, oops, and let's also make a version of this for minus. And let's see, wins, that's going to be the exact same. Losses, that's going to be the exact same. And then this is the part that changes. Oh, and so let's see, that was giving me the total, and then I forgot to do the division from before. So divided by reps times the bet size. And okay, let's do it here again. So wins times the amount that we win in each case. So in this case, it's times 100. And then minus the losses times the bet size. So there are different ways I could write this. But for these minus bets, I was assuming I was always betting minus of the odds. And so I don't quite trust that I wrote it correctly, so let's check it and see how it matches. So let's try sim minus 0.5 minus 110 for 100,000 repetitions. So I was losing on average 4.6% of the investment. Oh, and I can already tell I didn't write it correctly because, again, I forgot to divide by reps times the bet size. Okay, now let's try it for this sim minus 2. And I'm hoping I see a similar number for the return on investment. Yep, looks very similar. So that makes me think I wrote it correctly. Let's just check it for a plus and make sure these also look right. Let's say it's a plus 100 bet. So this should be almost exactly fair. Yep, so these look very similar. So I think I have these written correctly. And now the last thing I want to do is write a single function that combines all of them. So I'm going to call this sim, and then there's going to be true probability, odds, repetitions. So that stuff's the exact same. And this one, it's not going to matter if it's plus or minus. So let's say if odds is less than 0, then I want to use the minus bet. So then I want to use sim minus 2, because remember that's the one that's faster, because I'm using that built-in NumPy count non-zero function. You have to be very careful to write them in the correct order. For example, if I switch the order of these, that would have a totally different outcome. And otherwise, and so I forgot to say return. This is the thing that I want to output from the function. So this way I want to return sim plus 2. Okay, same thing. True prob, odds, reps. So this should be a single function that works for both of them. So let's check. So say it's like a slightly bad bet. It's a 50-50 bet and you're getting minus 110 odds. Okay, let's try 10 million. Okay, that's right around the boundary of what you should expect Python's able to do in a reasonable amount of time. Okay, but it did that fine. Yep, and that looks like that looks about right. So on average, we're losing 4.5% of our investment. And the whole point of this is checking, does it seem like it's working for both plus numbers and minus numbers? So there was a minus number, what about a plus number? So this is a very good bet. So on average, we're getting back half of our investment. So that seems like it's working correctly. Okay, that's the end of this first section. And I think I will take a short break and then come back and talk about how can we collect some of this data into what's called a pandas data frame.